Hey everybody, this is Larry, this is me going for Q4 of the weekly contest 386, earliest second to mark Indices 2. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about this one. This one was very hard, I think less than, like not that many people got it and just didn't even get Q3 for some, probably just ran out of time I guess. But yeah, a lot of people didn't get this one, so this is very hard. Don't feel so bad. If you look at Q3, it is an easier version of this one. I hope I think you have to fully understand that one before solving this one, or at least a lot of the ideas are the same. And the initial idea is binary search. The binary search is, I'm just gonna show you the binary search real quick. I actually copy and paste the binary search, so I didn't even, I don't know. I copied it from Q3, so yeah, thankfully it's right. I didn't have to change anything. But the idea is still the same thing as Q3, right? And if you look at it there, it's the idea that, okay, let's say if this prefix is correct, then that means that everything afterwards is correct. Like if you have more time, then you're always going to be correct. And conversely, if this prefix is wrong, that means that everything more than that is wrong, so you have to go smaller, right? So that's basically the idea about it. Yeah, if this is not enough time, then you have to get more time to, oh, did I say it the wrong way? Yeah, if you don't have enough time, then everything more than this will not be enough time, right? So that's basically a property that kind of gave me the idea that I can binary search. I'm not gonna lie though, I did have 4 wrong answers here, and it took me a long time. Some of it is strategy, to be honest, because I was like, I feel like this is greedy. I think I could kind of buy a wrong answer for 5 minutes, and that's basically what I did. But yeah, and there were just a couple of greedy things, and we have to kind of make observation, right? And to be honest, during the contest, I was a little bit tired, a little bit lazy, and I just kind of gave wrong answers away instead. And it cost me 4 wrong answers. Maybe I could have gotten it faster without it. I would have fewer penalties without it, but I'm not sure that, wow, actually, like, even though I just got 1 fewer wrong answers, but it went up a lot. But yeah, it's just, unclear. But yeah, what I was gonna say is that this problem is just different enough, but it's very hard, so very difficult. Otherwise, more people would have got it. But yeah, but basically, let's go over each rule. The first rule didn't change. The second one is that you can set nums. You can change one number with this index in these inputs to 0, right? Or to non-negative, but in a greedy way, you always want to change it to 0. And here, on the last one, is that you can always just basically choose any 0 number and then mark it. So the problem actually changed a lot, even though the idea of binary search is the same, which kind of like threw me off a little bit. But basically, you have to make these observations kind of pretty much one by one. But yeah, and like I said, I made 4 wrong answers, so I didn't even, wasn't that good about it. But yeah, I think the best way to show this is that I have some test cases, so that I got from when I got wrong answers. So let me pull them up real quick. I don't think I have it here. The reason why I want to go over these test cases is because I just want to show you how easy it is to mess up greedy. So basically, this is 477. All right, let me just put it here. But yeah, the answer is greedy, but you still have to be greedy the right way. So that's basically it, right? 477. So the answer is 4 here, 7 here, and here, right? So the idea here is that for this one, this is 4, and it is not 3 because you can only mark this one here. Oh, sorry. So basically, the idea here is that you use this one to convert this number to 0. You still need one more number afterwards to mark it. And basically, that one is actually not that one is an obvious observation. I just kind of got lazy. And then there's another observation, or like I just kind of forgot about it because there's a lot of things to remember and I'm old. But yeah, but then the other thing to remember is also that, yeah, and basically you use one of these first move to mark this off, and then this one to convert this to 0, and then this one to mark it off, right? So that's 4 moves. The other observation is, of course, that even though you have these change indexes, you don't have to use them. But if you were to use them, you would use them first, right? Like, it doesn't make sense to use this one over this one. You would always use this one first so that you have more flexibility in marking them in the future. But also, you would never use it because the number is 0. So that's basically another thing that you may do. I think after that, to be honest, I kind of the other edge cases are kind of awkward, but to be honest, they're all kind of simplified to the same one. It's just that I kind of did them in a crazy way initially. So I think, like for example, I think this doesn't need to be. I think this is, if this is 0, it should still be good. Hang on. Oops. Oh man. Okay. Oh. Right. Let me run this real quick. Okay, so it's still good, yeah. But I changed that to make another observation that I didn't need. So maybe I didn't need 4 wrong answers if I had made the correct observation after that. So the correct observation is actually, I think Alex has a case that he gave me. Hang on, let me pull it up real quick. Basically, yeah, he gave me a case that's something like this, very long. But the idea here is that you want to, in theory, in a greedy kind of way, you have 4, 5, 4, 3. Oh wait, no. You want to greedy from the left. So this is the 3. This is the 4. And actually, I don't know that this is true for this particular one, to be honest. But basically, the idea is that if you, let's just say you use this prefix, right? The idea here is actually that, and I think this is where it, because I think the idea here is that in a greedy way, and this is what I did initially for one of the wrong answers, is that I go, okay, in a greedy way, this is how I will mark things, and then in a way, greedy way, I go, okay, well, let's say I mark these, and then you could just simulate, right? So you mark 3, you convert this to 0, you convert this number to 0 and so forth, and then you mark it later if you have space and so forth. But then here, so one more thing that is similar to this problem, right, is that, well, here you only have one free thing to mark either the 5 or the 6, right? So then the idea for this the tricky part here is that, and this is how I did it initially with my first greedy, is that I go, okay, there's a 5, there's a free space, I go 6, oh, I can't use this anymore, so then I have to unmark this 6, right? But in unmarking this 6, that means that this 5 is now, this is not a mark, sorry, this is the 0, right? So this means that we want to use a 6 and a 0. So then here we go, okay, we convert this to 0, but now we can't anymore because we need a free space. But it turns out that that is the wrong way to do it. It turns out the right way to do it is that yeah, so this is a 6 for now, but actually this 6 can be using this free. It's just that this 5 wants to use this free space to do it, right? So basically here, instead of converting the 5, because if you go left to right and we have, let's just ignore everything else and we have this left, assuming everything's the same, then now what this is saying is that, okay, we want to convert the 2 to 0, because here we have, so then now we can mark this to 0, and then we have another thing, and then we have to maybe use this 6, we have to do this 5 in the previous space or something, right? However, in a more greedy kind of way, the idea here is that, okay, so you have two things to choose from. Let's choose the one that's most expensive. And the one that's more expensive is going to be the 5. So we actually convert this 5 to 0. And then we use this space to mark it. And then here, so we don't convert the 2 to 0 anymore. And we just use the least expensive one, right? Yeah, so then that means that previously we just used a 2 to kind of do it. And then basically we just simulate this again to figure out how to do it. So okay, so all that is kind of confusing, to be honest. It's all greedy, but I'll show you the code and we'll go over it together. So first of all, this is the binary search. I'm not going to go over it. This is Q4. 30 people or 40 people solve this problem. If you have issues with binary search, you have to figure that out before solving this one, right? I think that's a fair thing to say, right? Because even the people who knew it was binary search and very good at binary search did not get this one, right? Yeah. Okay. And yeah, basically we do a binary search. Sorry, I'm having like a little bit of coughing thing. Like internally, I'm trying to like, sidelines, nasal drip or whatever. Yeah, so then here you have a target. This is regular binary search stuff. You see if target can pass. And initially this is the same setup as before. Scene, so okay, so let me actually add some notes here. Can we mark all indexes in the first target seconds, right? So then here we have seen basically just saying that for each of the number are they marked, or actually for each of the number have we used the set to 0 operation, right? Which is operation 2, I think. Yeah, it's a little bit awkward, but yeah. And then the lookup is just looking up mapping, lookup indexes I. So yeah, I to being used. That's all. I mean, I kind of wrote this in a weird way, but basically you just kind of go through the first thing, and in a greedy kind of way, we always want to use the set to 0 operation as early as possible, and we only want to use it when it's greater than 0, or even greater than 1. It doesn't change the answer, but yeah. So that's basically the idea, right? And if we do, we set it to I, and then we kind of just do it this way, right? And then here, this is actually the part that is very tricky. This is the part that we were saying about choosing the minimum one inside the things. And this is where we have this heap coming from. And honestly, when I first wrote this and I got 4 wrong answers, right? I kind of just did it like backwards. I greedily chose the first thing that we can pop to pop, right? So we don't have enough free space. We just remove one of the ones that we use. But here we actually want to remove the minimum. And the idea that I got from this problem actually is this Rick and Morty problem. I call it Rick and Morty problem because of, well, you could see this Rick and Morty thing. But the idea here is the same as 1642. Furthest building you can reach is that you don't have to make a decision of which one to use until you're forced to make it, right? So basically the idea here is that, like I said, if you have like 5, 6, 6, and this one is free to, you only have 2 things to use, but you have to choose the one that is smaller, right? So once you do that, then because you have 1 free space, and the free space we kind of put the most expensive stuff on the heap, and then we kind of pop out the cheapest thing, and that's basically the idea behind this one. And again, we're going backwards. If this index is being used, if this index is not being used, if this index is not being used for set to 0, it can be used to mark, I don't know why mark is a thing. Okay, mark any zero number, right? So that's basically it, right? So that's, and I call it free because it's the number 3 marks that you get, right? Otherwise, yeah, we put it in a heap. We put the current the cost in the heap and the index of the current item, and basically now we want to see if we can use a number, right? So if 3 is greater than 0, then that means that we do have a free number, so we have to subtract, or we can subtract 1. Otherwise, well, that means that we have to pop a number, because that means that we don't have enough free space. We have to take 1 out of the numbers that we've used and choose the cheapest one, and then because of that, this index is free for use in the future. So that's why you have 3 plus equal to 1. And that's pretty much the core part of this one. This one is, I probably like, if I had this one thought out more, then it probably would have been like 3 wrong answers or something, because I did other greedy stuff, but that's basically it. Okay, so then that basically, now it also, what this does is that, so this pops, but it also means that we no longer, because the idea here is that look up sub I is the earliest, or I is the earliest that we can use the set to 0 operation. So if we can use it here, then we can use this operation at all. So then we just basically, all this does is resetting, saying that, okay, we cannot use this operation for this index, both the number index, or the index of nums, and also, you know, the index in target, right? And then here is just saying how many operations do we need, right? How many total operations do we need, right? And basically it starts at n because it includes n marks, right? And starts at n because we need to mark all n items. And then here is basically, yeah, if we don't mark this to 0, we need to decrement num sub I times. So that's basically the idea here. And in total, you have n plus, you know, the summation of all these things that are seen. And then this is just a simulation, right? This is basically, okay, if we mark to 0, we can skip to the next step, right? Otherwise, we use one of the operations either to decrement or to set to 0. Oh, sorry, to mark one of the previous cells. It doesn't really matter because in any order it's fine, right? So that's basically the idea. And basically we have less than 0, then we're done. Yeah, again, this operation is going to be O of m plus n. So that makes this O of m plus n log m, and O of m plus n space, I think. Maybe I'm off by something here, but I think this is actually O of n space, but okay, fine, if you want to write it that way. But yeah, that's all I have for this one. It's very tricky to get all the greedy exactly right, clearly. But yeah, I'll show you the code one more time. So this is the beginning. I don't think I used this. I thought I might have, but and I'm not using it. But yeah, this is the good function. This is very long, so I'll show you the top and then the bottom if you want to pause and kind of take a look. This is the binary search, and I'll make this small so you can kind of see it in one screen in case you want to. Wow, this is a lot of code for this one. All right, well, here, right? So yeah, all right, let me remove this print statement so you can have it in one line. All right, there you go. But yeah, that's all I have for this one. It's a very tough problem. Not many people got it. So yeah, and also, like, maybe if you want to review this problem for what I said, review that video. I have a couple of videos on this one as well. So yeah, that's all I have for this one. Let me know what you think. Yeah, stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye. Oh wait, yeah, actually, you could also watch me solve a live in contest, and you could kind of see, actually, yeah, I didn't go over all my wrong answers because I have 4 wrong answers and I don't remember them exactly. But you can kind of see how I debug each one. And there were some observations I could make for each one. So maybe that's interesting. Never check that out. Watch on 2x or something like that. I don't know. But yeah, you can watch me solve it live in contest now. Is this right? I don't know, to be honest. It's very possible that I have an off by 1. So let's just give it a submit. Okay, good. Whew, that's a tough one for sure. I actually thought I might maybe have an off by 1, but it is definitely a hard one. All right, same problem, but now you can do it to any non-negative. How many people got this yet? 1 person got it. 5,000 now, so we probably can't binary search. Maybe we still should be able to binary search. What would change? Let's see. And the idea is the same. Why did they make it 5,000? That is annoying, actually. But wait, why doesn't this work? Oh, because yeah, then those examples are different. Okay, that makes sense. Let's mark something like that. Okay. So it's the same idea, but if it's the same idea, why didn't people get it yet? So I'm kind of skeptical. Wow, Alex is what? Good job, Alex. I gotta stop focusing on Alex and focus on myself. But okay, fine. I'm just looking at the running time on that one. Oh, actually pretty fast. Because the 5,000 scares me, to be honest, but maybe that's fine. So what does that mean? Right? So we greedily choose the last one again. Wait, what? Okay. Oh, you can just set it to 0. Why would you? Oh, I guess this is for if you have 9 things. Okay. So how would that look like? What would that look like if that's the case? Okay, I don't think I understood this formula, but okay, now I think I do a little bit better. If I run it backwards, I mean, still true that I think this structure still is true, but then now it's this thing, so we have to change this code a little bit. Maybe we don't know that that's true. Wait, how can you do this? Maybe I'm misunderstanding this. Oh, it's not only okay. So it's different. This thing is different too. You can also do nothing. I don't know why. So you can mark anything that's 0. Okay. So that's the different part. Don't know how many people got it, but so that's the different part as well. I was wondering how this one worked, but okay. So then this is not true then. Okay. 5,000 is kind of crappy though, because it's just anti-Python, to be honest. Like, there's no reason. But these cases, it doesn't matter then that these two are things, but can I do dynamic programming? No, maybe not. Probably could have gotten the Q3 faster, but today's a slow day. Let me get the board. I'm not getting in 2 seconds. This is a totally different one. Also here, you would always choose this to be 0, so... Okay, so what does that mean? I mean, if you would use this step, and here's for... Man, this is a way different problem. Oh, this is not 5,000 square, but still. Maybe the other one was. I guess the other one could have been n square, but I did binary search anyway. And I think this one, the binary search still holds true, but I just don't know how to do it in a greedy way. Right. Okay, let's say you have 4 moves. Do we always want to do? Let's say we have 4 moves. Do we look forward? If we look forward, we go, okay, well, let's make this into a 0. So, okay, so some sort of greedy, maybe. Okay, so let's say you have these things, and then you see. I think I have an idea, but if that's true, I don't know why people like. I don't know why it's so hard per se, but okay. So we want to set it to 0. We want to set this to 0 as early as we can, I think. And then everything is just decrement, right? Don't know why that's not true. I guess we'll code and figure it out. Yeah, it's not an easy coding though. That's why I'm like stalling. Okay, so here. Okay, we haven't seen this yet. Then we said seen. We'll do it this way. Basically, I'm going to do greedy, right? Okay. And okay, I mean, I think this is maybe right. I don't know. Yeah, okay, maybe that's fine. We haven't. This is wrong. Do we have to reverse it? I don't know. Maybe not. And then basically the idea now then is now we just do like a for I in range of okay, well I think we'll just do this if think this is what I will do for this one. Okay, and then now we go again, right? So if we go again, all right. This is, I didn't even use this, but okay, fine. Also, this is wrong. This should be is none. Alright, so this is none. Then we want to add it. Yeah. Yeah. Okay. Okay, and then now, oh, this is actually to n. Now we want it, right? So if this is off, but okay, fine. Oh, it's not off, but I think I need the other way too. If I look up, then what does this mean? That means that we set it to 0, and that's good, right? And we continue because it just assumes that we set it to 0. Otherwise, we don't set anything to 0. Marcus, you go to n, right? That means okay, so we don't set anything to 0, so we decrement one of the ones. Okay, fine. This is very awkward. I think I can just do let's go n. Yeah, okay, fine. Yeah, okay. Oh wait, no, this means it's true. I think this is, if this is greater than 0, then this is false. Alright, just keep it that way. 1, 1, 1 doesn't seem right. Why does it think it's 1? Alright, that means nothing. Okay, fine. Target. Okay, so we have the target of 3, so we have these 4, right? 0, 1, 2. Yeah, okay, so the first 3, alright. So needed, we need 3 things. Oh, wait, do we? Well, yeah, that's fine. So this returns false, right? Oh. It is good if it is, I don't know, less than 0. Whoops. 7, 7, negative 1. Alright, well, I mean, it's wrong, but it's good, it's good. Maybe, I don't know. 6. Negative 1 is good. Okay, 7 is good. 6 is wrong, though. My 6 is wrong. Alright, so needed is 0, so that's good. Oh, it's good if it's, yeah, okay. So 6 is good. I knew 6 was good. Why is this giving me 7 though? Is it because 7 is, so 6 is good. Well, 6 is good now. I mean, 6 is definitely good, but is 5 good? 5 is no good. That's the one that needs to, because it's 0 to 5. Okay, so I think I just got off by 1 in my testing, but okay, why is 5 no good? Because that's 1 left. Why does it have 1 left? It needs 3 moves. Why does it need 3 moves? Oh, to mark it. Okay. So then 1, 2, 3, 4. So that means target. What's target? Target is 5, so 0, 1, 2. Oh, okay. So this is target plus 1. I think I'm confusing myself off by once, but okay. Okay, so target is 5. So we'll do, I mean, this should handle all the 0 to 5, right? So 0 to 5, non-inclusive. Maybe I needed to do this. Maybe I just did it wrong, because this should be, yeah, okay. Okay, 6. Yeah, it's still wrong, but it's still, yeah, okay. At least I know that this one's right. That's good. Alright, so this one 6 is good, that's true. 5 is also good, which is also true. So then it should have gone down, right? No, because 5 returns 6. No, but 5 should not be good. Why does it think 5 is good? It's good because it skips these 2, and then now, but it thinks it has 4 moves to do. Is that true? It has these 4 moves plus 3, right? So it should be 7. Alright, let's take a look. Yeah, so if this is none, then needed should be... Huh? Is it doing something funky? Yeah, it's definitely not adding that for some reason. Why? What? I am dumb. This is not change index. Okay. Wow, that is a silly mistake, but okay. We got through it. Well, now we got through it, but it's wrong. Okay, that's fine too. Alright, at least we got the first one consistent and the second one's still right. I mean, the first one's still right, the second one not so much. Alright, let's see, 7. So it should do it in 7 seconds. Which is this one, maybe. Either one, really. So it has 7, so then it skips the first 2. Oh, because it's a 0, so we can reuse them. Yeah, okay, fine. If okay. If this is lookup and I don't know if this is a special case. Sub. Okay, because then we update this. Otherwise, then we don't, right? Alright, well, look, I don't know how to solve this, not gonna lie. But it works for the sample cases, so let's YOLO and we'll get a wrong answer. Okay. I just wanted to get something. I just want to feel alive. Okay, no. Alright. 1, 1, 2, 2, 1. I put 3. Why can I do in 3? Yeah, no, I cannot do in 3. So because it needs one, I did note this case, but I kind of forgot about it, to be honest. Okay. So basically it marks it, but it needs one more step beyond that. Oh, but that's tricky. Because, okay, let's say we just add one beyond that, but then if this is 0, 1, then you could do in 3, right? Because if it's 0, 1, I don't know if I know how to do this one bit. Oh, let's see. Oh, wow, you are very good. Because if it's 0, 1, then actually one of the previous ones will just subtract 1 from that. So, that is tricky. Okay, how would I do it? Well, this is worth 5 minutes apparently, to be honest, because I don't know how to do it otherwise. But, oh, 2 long answers on Q2. Okay, but, okay, that you're asking the wrong question, Larry. You're not asking to minimize. You're asking, given target, can you do it? So let's say we have these 3 things, and here basically what we want to say is you cannot use this because there's not enough time left, right? So basically what you want to say is what you want to say is what you want to say is, okay, if C change indices of I is not none, then okay, so if this is none, then we can add the number of space, right? Else, so that means that it is not none, but if 3 greater than 0, then we could decrement. Else, seeing okay, but oh, this doesn't go to 2. Okay, fine. Oof, this fixes this one but breaks the other one. Why does it break the other one? Alright, so let's say we have let's point this out too. Okay, let's say we have 5, right? And we have 0, 1, and did I do this in the right order? Okay, let's say we have 3. Okay, that's fine. we do 1 is equal. This is like in a weird order though, I think. Because we want to remove the 2 first. Oh, but the 2 is the 1. No, but we want to remove this, so I think we messed this up. Yeah, so then you have this thing, but then going backwards, this should have been okay, we remove 1 and 0. But okay, so this is 1 and then this. Okay, so that means actually, okay, so this is gives us a free space because we don't use this anymore. Okay. But okay, so we remove, so let's say this is target 3, so we have 2, 4, 2, no bueno. Now this, oh, 0-3 has 2 2s, that's why 2 is good. But this one, the 3 is no good. So then we get a free space back and then, okay, fine, maybe, I don't know. Still wrong though, so we'll see what happens. Alright, it is kind of chaos printing here. Okay, so 6. Right. 6, we do 3, 4, 5, 6, but okay, we wanted to do 1, 3, and 2, okay. So then why are we removing the 2 and the 1? That seems weird. Why do we remove the 3, 2, and the 1? If no, this isn't right. Oh no, this is right. But this is only 3, 0, 0, but okay. Oh, this isn't right. This should be if I is in lookup. Oh, if I is not in lookup, then we do this. Okay, because yeah, okay. And then this is just yeah. Okay, well, I don't know. I mean, this is still greedy, so I don't expect this to be right, to be honest. But it is a good. It'll give us a free. It'll give us a free wrong answer. So let's see. All right, because I don't know how to think about all the cases, to be honest. And a lot of people get it wrong. I mean, I don't know. We might not get this one, but at least we get wrong answer, so that's fun to debug. Okay. So we have 8, but it expects 7. 3, 4, 5, 6, 7. But it thinks we cannot do an 8. Okay, let's print it out. I mean, maybe some greedy thing that I messed up here, because right now we kind of free them up by greedy. It may be wrong. It probably is wrong, to be honest. But, you know, sometimes you just gotta YOLO a little bit. And this is a very hard one, it seems like, so. Am I thinking about it wrong? Is it not variation on greedy? And whenever you change, you always want to change it to earliest. But when you cannot remove, I don't know. Alright, let's debug this one real quick. Real quick, right? Okay, so 7 is good, which is 8 seconds, okay? But 6 no good. Why is 6 no good? Tell me why. Gotta remove some stuff, is that right? On the 6 we remove 0. Okay. So on this should be here. 1, 2, 3, 4, 5, 6, 7. Huh. Why do we remove 0, which is this one? That's not the one we want to put, what? Okay. So we have this thing. Do I remove 0? I'm just, oh. No, I mean, I guess I do remove 0. So we removed this one. Is that right? So okay, so 1, 2, 3, 4, 5, 6, 7, right? So okay, we never have to care about the 1. Do we? Nope. Okay, we don't accidentally care about it. That's good. Well, no, we have this here. Why do we have this here? Oh, because we do some funky things. Okay. And num sub change indexes of I is greater than 0, then we otherwise we just ignore it, really. Alright, I mean, I should have done that, but I guess that I mean, the other logic should have taken care of it, but we had added more logic, so that kind of made things really complicated. I think this is right. Or like, I think this matches this example. There's so many. We're literally that guy that's doing like one step at a time, but it may be that greedy as well. I don't know that there's another way. I mean, clearly there's another way of doing it, but I don't know how to do it, so. Alright, so 7 is these 7. I need to make sure I remember this as well, just forget, but okay. Because I think the other stuff is right, so let me just paste it somewhere so I don't forget. And it should be 7, the last one. Okay. Okay, so we have 2, 3, 4, 5, 6, 7, right? So we Alright, what am I doing? Just print it out, Larry, and then worry about it later. Alright, so it looks good for 7, but not 6, because for 6 we remove a bunch of stuff, I suppose. I was too lazy. So okay, we remove 4 and the 3. Where's the 4 and the 3? That seems like a very silly thing, because this is a 10, so we definitely want to remove it. So maybe we cannot do it in a greedy way. 1, 2, 3, 4, 5, 6, 8 or 7, right? Okay, so I don't know why they don't let me just highlight 6, 7. Okay, so what's happening here is that 2 and a 2 because of this is a 1. But we don't need it to. I guess we save 1 move if it's 1, so maybe I don't need it that way. Let's see. Okay, so it's correct again. Is it right this time? I don't know. I mean, I have no confidence. We already have like 3 wrong answers or something, but it's free. Alright. We're done. I mean, I mean, I'm not trying to cheat, of course, like one of those if statement things, but I'm just trying to be a lot lazy, to be honest. But how many wrong answers do I have already? 4 wrong answers. With half an hour. I mean, the wrong answers don't matter if we don't get it right anyway. But I'm happy that I solved this. But I think it's just not greedy. I think that's probably why. Or at least like if it's greedy, it's something funky. Some people got like 6, 7 wrong answers. I guess their wrong answers kind of help them debug it, but for me, not so much. So that's a little bit sad. Can I think any other way? I mean, I'm doing greedy stuff, so that may just not be right. What I want to do, though. Yeah, this is really funky. Okay. Reset, Larry. How do you want to do it? So let's say you have a thing. If you mark something, or you mark that you want to use it, yeah, I guess 1 makes sense here. But yeah, and you look back and then just to make sure that you have it. Okay, well. Okay, I mean, okay, if this is a 1, then you just mark it, right? So, is there a TP? Let me copy this as well, just before I forget it. I don't know if we're close or not, to be honest. I think that's the hard part for me right now. We have half an hour. I mean, we got a lot of test cases. So, I mean, but are there weird edge cases, or is it that I'm missing something more fundamental? I think that's what I'm trying to tell. Because if this is 1, then using it is exactly the same as marking it. So, okay. But it's a little bit awkward because it could be a 2. But if it's near the end, okay, you're free, then we can use it anyway. Yeah, I mean, I don't know. What am I missing? That'd be funny if it's just DP somehow. I don't know. Yeah. Is this right? I mean, I guess this is right now because we have this other thing, so this doesn't matter. So if this isn't a lookup, that means that we marked it. Otherwise, we either do one that we need or we mark another one. Or we change it to 0. And these are the earliest times we can use it anyway, so okay, so if I isn't lookup, looking backwards, if I is not lookup, then we have 1 free moves. Otherwise, we do have a free move and then we have to remove this one. Because you could have a free one and then you have a choice. I see. Does that matter? I guess so. I see, okay. So maybe we have to put a heap here? I mean, I don't know, it can only help, I guess. Okay. You might need it, Larry. So, okay. So now we free one of these. Okay, so we use one of the frees. And we also want to do okay, so look up sub I don't even, so that's the change index. I and the lookup sub I, though it doesn't matter. I think if I is set up, then it's obviously this anyway. I think I did it in a very funky way, but okay, num sub look up sub I, right? So otherwise free is 0 and we have to pop something. So okay. And we don't want to, yeah, we do want to, it should be min, because in theory, yeah, because we used to, okay, yeah. So we don't, do we care about this? No, we don't care about that. Index and change, whatever, change. I don't think I actually need that, to be honest, but okay, fine. Oh, okay, you don't need it. So this is the index that we pop, and basically scene of change index sub I is equal to none. It's index, Larry, not I. I made that mistake before. All right. Huh. So we pop without a heap, right? Wait, how is that possible? If the free, then we sub, if free is greater than, okay. Oh. Wait, what? Oh, wait, so this is only if we don't do it. Okay, oh, I see. So we want to push this anyway, and then we do it that way. Okay, fine. All right, let's give it a YOLO submit. I have that like, whatchamacallit, Because this is exactly what is his name? What's that cartoon name with the Morty and what's it called? Morty and Rick and Morty. That stupid like thing in my head. Like that's what I was picturing, and I was like, oh, actually, if you kind of reduce it that way, then if you reduce it that way, then you will actually want to return the min, and so here we are, and there you go. All right. But I ate a lot of wrong answers though, so I don't know. I mean, yeah, thanks for watching. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this farm. Stay good, stay healthy, do good mental health. I'll see y'all later and take care. Bye bye.